going to discuss here is the topic called homologous series. Okay. So what do you mean by homologous series? I can say that homologous series, you can say it's a series or group of organic compounds having one particular functional group and they have the similar chemical properties and they differ by CH2 group. Okay. We can say each member of this homologous series as a homologue. And always they will have the same method of preparation. Method of preparation will be the same. However, their physical properties will vary. For example, I can say methanol. What is the formula? CH3OH, correct? And the next homologue, how I can add? By adding a CH2 group into that. So it will become CH3CH2OH. So it becomes ethanol. So methanol and ethanol, if you see, they are differing only by a CH2 group. I can say they are a pair of homologues. Okay, and they will have the same method of preparation. Why we say that? Because both are alcohols and their method of preparation remains the same. Now all can be represented by the same general formula because alcohols means they will have one same general formula and it will not vary if you are adding a CH2 group or if you are removing a CH2 group. Clear? So very simple, homologous series means they are a class of organic compounds having a particular functional group and each successive members they differ by CH2 group. And they will have the same chemical properties but their physical properties may vary. Okay, they will have the same method of preparation. Okay, and each successive member is called a homologue and we can say they can be represented by the same general formula. Correct? And each member will be differing by molecular weight of 14. Why? Because they are differing by CH2 group. So molecular weight of CH2 group is how much? Carbon 12, hydrogen 2. So 12 plus 2, 14. Understood? So very simple. This is just a definition you need to understand. That's it. So next we are going to learn about the different functional groups and its general formula. Very important for the attending numericals. Okay? Okay. So as discussed, we will just see the general formula of various organic compounds. Okay, so first comes in the list is alkanes. So you know about alkanes. Example is what actually? Simple one we know it actually. Methane, CH4. Then next one, ethane. Now you can see that they are differing by what actually? Successive unit CH2. Correct? If you add one more CH2 here, what will happen? This becomes C3 and this becomes H8. So this is the trend actually. So how this number is differing? Here 2 means this becomes 6. That is 2, correct? 2 into 2, correct? Plus 2. Like this. Now here if you see how it is coming actually 3 it is becoming. Now next 2 into 3 plus 2. So which number is varying here? This number keeps on varying. This 2 number keeps on varying. So I can say if I am assuming this number as n, then what this will be? I can say 2, if you see here 2n, correct? This is n, so this becomes 2n plus 2. So this is how I derive the formula, general formula as CnH2n plus 2. Clear? You can just see here C2H6. So this 2 I have taken, then 2 into 2 plus 2. When this becomes 3, here it becomes 3. First one I am taking 3, okay, then what is happening? Then I am taking this 2 is remaining the same and this number is varying. So that means if I take this as n, this becomes 2n plus 2. That is how CnH2n plus 2 is coming for alkanes. I hope it is clear for you. Now next we will try to see the general formula of the next one, that is alkenes. This is the general formula of alkenes as well as cycloalkanes. Okay, so simplest alkene I know, that is CH2 double bond CH2. What is this? As you know, this is ethene, correct? So there is 2 carbon and 4 hydrogen. So I can say this is C2H4, correct? Now the next alkene I can say CH3 CH double bond CH2, that is propene. So how many are there? 3 carbon and 3 plus 1 4, 4 plus 2 6. So C3H6. So you can see here always this is a multiple of this. So if I am assuming this as n, this should be what actually? This is 2. So this is 2 into 2. 4 is 2 into 2. And what is 6? 3 into 2. Correct? So I can say this 2 remains the same and this is keeping on changing, and this is same value as this value. So if this is n and this should also be n, then this should be 2 times n, because 2 is fixed and this keeps on changing. CnH2n. Understood? So this is the way we derive the general formula. So I can write that here, CnH2n. And similarly for alkynes, okay, alkynes and cycloalkenes have the same general formula, and that is CnH2n minus 2. So I can similarly derive that. For example, simplest alkyne is CH triple bond CH. So if you see the formula, that is C2H2. Now next one, if I see, that will be CH3 C triple bond CH. Now what is the change happened? Carbon atom increased to 3 C3, then this becomes H4. Correct? So how this can be related? So if it is CnH2n minus 2, so what is happening? 2 into 1 minus 2, like that will happen. Correct? So if the number is 2, means 2 into 2, 4 minus 2, that is again 2. So that's how the basic formula is becoming CnH2n minus 2, because when you substitute here carbon number, if you are keeping it as 2, so this becomes 2 into 2, 4, 4 minus 2, 2. So that is C2H2. You will get the same. Okay. So please remember the formulas. Others also we need to see. We will see one by one. Next we will try to see the general formula of the next organic class of organic compounds. So I am rubbing this. Okay. So please learn this general formula, very important actually. So the next one is the next chapter, that is alkyl halides. Alkyl halides. So for alkyl halides, what is the general formula? We know, we will take one example, then it becomes easy. Okay, CH3Cl. Alkyl halide means first we will remove one H from an alkane. For example, this is an alkane, assume CH4. I am removing one hydrogen from this. So this becomes an alkyl. We have learned this. Into this a halogen is coming. Halogen, I am saying chlorine. So this becomes CH3Cl. Understood? So this is what alkyl halide. So this is derived from again what? Alkane. Correct? So with that as the fundamental, we will try to derive the formula. Okay? So let's say our general formula for alkane is CnH2n plus 2. Now we know that from this one hydrogen is removed. So what this will become? One hydrogen is removed. So this becomes CnH2n plus 1. Into this a halogen is added. So what is the formula? CnH2n plus 1x. So this is the general formula. So I got it as CnH2n plus 1x, where x stands for fluorine, chlorine, bromine and iodine. They are the halogen groups. I hope you got a general idea how to derive the general formula. Now let's see the next one, that is alcohols and others. Both have the same. You know that alcohols and others are functional group isomers and they have the same general formula. Let's see. Alcohols and others. Alcohols and others. So how will you derive again? So let's write a simple alcohol, CH3OH. Now let's assume how we got this one. Very simple. Again we are taking the fundamental one as an alkane, CH4. From this, what is happening? One hydrogen is removed. Then you will get an alkyl group, CH3. Into this substitution reaction, OH groups will come and you are getting CH3OH. Correct? So similar way we will try to derive the general formula also. Okay? So let's say we have from alkane CnH2n plus 2. From this one hydrogen is removed, so that this becomes CnH2n plus 1. Into this we are adding OH group. So when OH group is added, this H is coming back. So I can write CnH2n plus 2, correct? Plus 2 and O. Correct? So I got the formula as CnH2n plus 2O. This will be the general formula for alcohols as well as ethers. If you want to check for others, you can take an example and check it. It's easy actually. One simple example I can take here is CH3OCH3. This is a dimethyl ether. So how many carbon atoms are there? 2 carbon atoms. How many hydrogen atoms are there? 6 hydrogen atoms. So if I put here 2, C2, then this will becomes 2 into 2 plus 2, H6 and O. So 1 oxygen. C2H6O. You will get the same thing. That's why I have told for alcohols and others, they have the same general formula. Clear? So I hope that is clear for you. Next we will try to see the next group, that is aldehydes and ketones. And we know that aldehydes and ketones are also functional group isomers because they have the same general formula. So let us take a simple aldehyde and from that we will try to derive the formula. So simple aldehyde I can take here is CH3CHO, ethanaldehyde. Now see here how we have derived this one. So again I can say from the alkane CH3, one H is replaced and CHO group is introduced. We can think like that. So we can say CnH2n plus 2. From that one hydrogen is removed. So that CnH2n plus 1 it will become. Into this you are adding CHO. Correct? So we can say carbon has increased, hydrogen has increased and oxygen has come. So what can be the general formula of this one? So here if you adding this one into this, this will become CnH2nO. So I will explain how it is coming. For example, the better way to understand here is how many carbons are here? 2 carbon, C2. How many hydrogens are here? 4 and 1 oxygen. And we know that 2 and this is 4. So this should be a multiple of 2 into 2. Correct? We will take the next aldehyde, CH3, CH2, CHO. Okay? Count the number of carbon atoms. So totally 3 carbon atoms are there. Hydrogen, 3 plus 2, 5 plus 1, 6. Again H6O. Now you can see that this is 3. This becomes 3 into 2. So what is that meaning? So if I assume 3 as N, then this becomes N into 2. Correct? If I assume 2 as N, this becomes 2 into N. So what will be the general formula? CnH2nO. This is the way we can derive it and understand for the form. This will be applicable for ketone also. If you have doubt, you can check it out. For example, simple ketone I can take is a dimethyl ketone. Now if you see here, how many carbon atoms are there? 1, 2, 3. So N is equal to 3. So 3. How many hydrogen atoms? 6 hydrogen atoms. So if N is equal to 3, this becomes 6 and 1 oxygen. So this is applicable for ketone as well. So I hope you understood. Please remember the formulas. If you are forgetting, you can derive like this. Okay? Okay, so we will try to see the next one. So next in the group is carboxylic acids and esters. We know they are also functional group isomers. So we say carboxylic acids and the esters, they have the same general formula. So what is that general formula? We will try to see. We will try to draw one simple carboxylic acid, CH3COOH. Tell me how many carbon atoms are there. So we can say carbon 2, hydrogen 4 and oxygen 2. Correct? Now if I try to draw the next carboxylic acid, what is that? CH3, add a homologue, CH2, then COOH. So what is happening to the carbon? Carbon becomes 3, hydrogen becomes 6 and oxygen becomes 2. So we know that here 2 means it's multiple, 2 times. 3 means 3 into 2. So again the formula should be what? If this is N, H should be what? 2 times N. And how many oxygen? Number of oxygen always remaining fixed. So that will be always O2. So this is the general formula for carboxylic acids or esters. Now you can verify this also for the esters as well. Okay. For esters, what you need to do? One simple ester you can say, for example, HCOO CH3. This is an ester. Correct? So if you see, count the carbon atom, 2 carbon atom, C2, then count the hydrogen, it becomes 4 and oxygen 2. So if I put 2 here, this becomes 4 and this becomes 2. So again the formula remains the same. That's why I told for carboxylic acids and esters, they are functional group isomers, they have the same general formula. Okay. So next we will see some of the unimportant functional groups that is not there in your syllabus, but just we will try to put that also. First one is cyanides and isocyanides. Okay, for cyanides and isocyanides, the formula is CN H2N minus 1N, and we know that in cyanide N is nitrogen is present in the functional group. So the general formula is CN H2N minus 1 capital N. Okay, so similar to that, there is another is there, that is amides, oxines, okay, and nitroso compounds, okay. So amides, oxines and nitroso compounds. For these compounds, the general formula is CN H2N, okay, H2N plus 1 NO. CN H2N plus 1 NO. Please remember this, not very important, but just you can think about it. That's it. So with this, I hope I have completed all the general formulas, homologous series. The first part is totally finished. Next we are switching to the concept of isomerism. Okay. So next we are going to explain the topic isomerism. Very important. You can get one question for this for Neet exam. Okay. So who proposed the term isomerism? Anybody knows? It was proposed by Berzelius. The term was proposed by Berzelius. Okay. So what is basically isomerism? I can say the definition as 2 or more organic compounds having the same molecular formula and molecular weight, but they differ in their physical and chemical properties. They are called isomers, and this phenomenon is known as isomerism. Just now we have seen earlier. For example, I have told alcohols and others are isomers. What sort of isomers I have told? Functional group isomers. That means they are totally different compounds. One is having the functional group OH and other is having the functional group O. Correct? But we can say that whenever we see the general formula, they are having the same general formula. That means if the general formula is same, that means their molecular weight also remains the same, but they will have different chemical and physical properties. We can say the behavior of alcohol, maybe with a particular reagent, we will get a particular product, but for others we will get a different product. That means their chemical properties are totally different, as well as their boiling points also differ. That means their physical properties are also varying. So very simple, if you say what is isomerism, it's a phenomenon. We can say isomers, they have the same, tell me, same chemical formula, or we can say same general formula, okay, and they have the same molecular weight, but they differ in their physical and chemical properties, and they are called isomers, and this phenomenon is called isomerism. Now let us see what is the classification of isomerism, how isomerism is classified. There are different types of isomerism is there. We will try to see one by one. Okay, so the broad classification of isomerism is, I need all sort colors of pen to make you understand. Okay, so if I draw isomerism here, isomerism, okay, so I can say this is broadly classified into 2. Okay, so this is broadly classified into 2. What are the two broad classification? I can say the one is called structural isomerism. What is it? Structural isomerism. Structural isomerism. And the other is called stereoisomerism. Stereoisomerism. Okay. And we can say this structural isomerism is further divided into, I can say this is further divided into the first one, the structural isomerism. I can say this is further divided into, the first one I may say, chain isomerism. It's called chain isomerism, very very important, chain isomerism. And it is further divided into position isomerism. Position isomerism. I will explain what and all these things. Okay, position isomerism. Then I can say it is further divided into ring chain isomerism. Ring chain isomerism. Then can you say the next one? Then we can say it is further into functional isomerism. I have told this term many a times. Functional isomerism. Okay. Then comes metamerism. And last comes tautomerism. Tautomerism. These two are very very important. Okay. So structural isomerism is further classified into chain isomerism, position isomerism, ring chain isomerism, functional isomerism, metamerism, and tautomerism. Clear for you? Now we will see the classification of stereoisomerism. So stereoisomerism is further classified into, I can go like this. So stereoisomerism is further classified into two broad things. The first one is configurational stereoisomerism. Configurational. And the other one is, can anybody say? Other one is called conformational. Conformational stereoisomerism. In this configurational isomerism is further classified into, that is called, it is further classified into two. One is called geometrical isomerism. And the next one is optical isomerism. Okay, so please look at this. I hope it is clear for you. That is, isomerism is broadly classified into two. One is the structural isomerism and other is the stereoisomerism. And structural isomerism, if you see, it is divided into chain isomerism, position, ring chain, functional, metamerism, and tautomerism. And the stereoisomerism classified into two, that is configurational and conformational. So this configurational is further divided into geometrical and optical isomerism. So some people may say optical is not a part of configurational. We can say it's another branch totally. Anything is okay. I will explain each one of these one by one with examples. Then you will understand. So first we are going to explain what is called the structural isomerism. Okay. So what you see by what is the definition of structural isomerism? I can say like, I am not going to say the chain in that. I am going to first explain what is structural isomerism. So structural isomerism means if you have two organic compounds, they differ in their structures, but still they have the same molecular formula or molecular weight, and they will be differing in their physical and chemical properties. They are called structural isomers. So they differing in the structure means it can be of different types. The structure can be differed in different way. For example, the chain length can be changing. The parent name, for example, when you select the parent carbon chain, that can be different between the two organic compounds given, but they have the same molecular formula and molecular weight. So the structure can be differed in different ways. For example, the position of the double bond can change. So I can say the structural isomerism, they can be different types of structural change can happen. So based on that, it is further divided into the first one, that is chain isomerism. Now you might be knowing, here the structure is undergoing a change by changing the chain. Chain means what chain? The principal carbon chain. So if you look at the definition, you can say compounds here also have the same molecular formula. The two compounds which we are taking, they have the same molecular formula, same functional group also remains the same position of the functional group or multiple bond, the position of the functional group or multiple bond or substituent will not change, but they differ. Where they differ? But they differ in the arrangement of the carbon chain. That means the principal carbon chain, if I take in one compound, it will have 4 carbon. In the other one, if I am taking, it will have 3 carbon. They differ only in the arrangement of the carbon chain. Then such groups are called, or such type of compounds, we can say they are exhibiting chain isomerism. So this you will understand when you see more examples. So let's draw some examples to make you understand. Please note down the definition. It will be useful for you in your board exams or in your classroom test. Okay? You can pause and note down the definition. Okay, now let's see examples. With that, we will try to understand the chain isomerism much better, so that it becomes easy for you to analyze and understand. Now the first example I am taking for this purpose is butane. Okay, so CH3, CH2, CH2, CH3. This is butane. Okay. Now I know that how you name this one. You will take this as the principal carbon chain and you will name this as normal butane or butane. Okay, normal you don't need to add, then it becomes common name. It becomes butane. Now I can say what is the formula of this one? How many carbon atoms are there? 4 carbon. So this is C4. How many hydrogen? 3 plus 2 5, 5 plus 2 7 plus 3 10. C4H10. Correct? Now let me draw another compound. Okay, and you need to tell me what is the relation between these two. Now tell me the next compound I have drawn. So if I first count the formula 1, 2, 3, 4. This is also having 4 carbon atom and hydrogen atom 3 plus 3 6 plus 3 9 plus 1 10. So this is having, so both are having the same molecular formula. If both are having the same molecular formula, they will be having what? The same molecular weight also, correct? But now if I am going to name this one, I need to identify the principal carbon chain, and I know this is my principal carbon chain. Now in this one, if you see 4 carbon chains were there, 4 carbon atoms were there in the principal chain, but here if you see only 3 carbon atoms are there. So what is the name of this compound? 2-methyl propane. So I can say these two are what sort of isomers? Chain isomers, because they are differing in their principal carbon chain. Nothing else is changing actually. Correct? So I hope you understood. They are also having the same molecular formula. So the molecular weight also remains the same, but both will be having different physical and chemical properties. Different physical properties in the sense, this will be having a higher boiling point and this will be having a lesser boiling point. Why? Because here more branching is there. As the branching increases, surface area decreases and the boiling point also decreases. If surface area is more, boiling point is also more. Okay? Because more surface means you need to boil that all those areas, so that more amount of temperature is required. That means the boiling point is high. I hope this example is clear for you. We will go to the next example and see it. Okay. So this is example 1. Butane and 2-methyl propane are what sort of isomers? You now know that they are chain isomers because they are differing in the principal carbon chain. Now let's see the next example. That is, I am going to take butanene. So CH3, okay, CH2, CH double bond CH2. So this is butanene, correct? Now let's draw, let's write the formula. How many carbon atoms are there? 1, 2, 3, 4. So 4 carbon atoms are there. Hydrogen atom 3 plus 2 5, 5 plus 1 6, plus 2 8. Okay. Now let's draw another compound. Now CH3, correct? CH3 double bond CH2. Now let's say this is the next compound that is given to you. Now can you tell me what is the relation between these two? We will again see. First of all, we will compare the molecular formula. 1, 2, 3, 4. Here also 4 carbon atoms. And hydrogen 3 plus 3 6, 6 plus 2 8, so again H8. So both are having the same molecular formula, hence the same molecular weight is there. Now the question here is how they are related, through what isomerism. For that, let me identify the principal functional group here. This one is my principal functional group, and if I am numbering it, this is how I will number it. So my compound here is butanene. So the position of double bond is first position. Correct? Now in the next one, I am going to now number it. I am identifying this as my principal functional group. I hope you know how to do that. We have already learned that. Now please number it. So this will be 1, 2, 3. So what is the name of this compound? 2-methyl propanene. Now compare this. You know that double bond, the position here is first position, here also double bond, the position here is 1. But the word root or the principal carbon chain has here only 3 carbon atoms, but here if you see 4 carbon atoms are there. That means they are also differing in their principal carbon chain. So these two are what sort of isomers? I can say they both are chain isomers. Understood? So I hope you are getting a fair idea. If the position of the double bond is changing, then that becomes a new isomerism, that is called position isomerism. We will come to that next. Let's see the next example. I hope this is becoming clear for you. If you still have the doubt, please feel free to ask me so that you will get a fair idea. Okay. So let's see the next example. For next example I am taking is butane 1-nol, CH3, CH2, CH2, CH2OH. Okay. So what is the formula? 1, 2, 3, 4. 4 carbon atoms are there. C4. Hydrogen 3 plus 2 5, 5 plus 2 7, 7 plus 2 9, plus 1 10. So C4H10O. Now let me draw another compound. Let's see. CH3, CH, CH3, CH2OH. Now tell me how these two are related. Now let's calculate 1, 2, 3, 4. Again 4 carbon atoms are there. Hydrogen 3 plus 3 6, plus 1 7, plus 2 9, plus 1 10. H10, and there is one oxygen. So both are having the same general formula. Now I can identify which sort of isomerism it is. So if I am choosing the parent carbon chain, this is my parent carbon chain. So this becomes butane 1-nol. Now what about this one? Identifying the parent carbon chain. So this is the longest possible parent carbon chain. So this becomes 1, this 2. So I can say 2-methyl propane 1-nol. Now if I compare this, the position of the functional group of both is remaining the same. It is 1 the position here, here also the 1 is the position. But the word root or the parent carbon chain has 4 carbon atoms here, but here only 3 carbon atoms are there. So again I can say these two are examples of butane 1-nol and 2-methyl propane 1-nol are examples of what? Chain isomers. I hope it is clear for you. We will see the next isomerism, that is the position isomerism. Hi dear students, so next we will try to see the position isomerism. So as I told, again it's a part of what? Structural isomerism. I told structural isomers comes by what? Changing the structure. So first we have learned by changing the parent carbon chain, it is changing the structure. So that is one method. That is why it is called chain isomerism. Next you can change the structure by changing the position of the double bond, functional group or substituent. Then we say that as position isomerism. So if you see the definition, you can see compounds which have the same molecular formula. Again the molecular formula will remain the same, or the molecular weight will remain the same. They have the same functional group. Both will be having the same functional group, and they will be having the same parent carbon chain. Parent carbon chain also will remain the same, but they differ in the position of the double bond. If they are differing in the position of the double bond or functional group or substituent, then we say they comes under the category position isomerism. Okay, so let's see examples so that it becomes more clear for you. Okay, so let me write the first example, and please note down the definition by pausing the screen, so you can note down the definition. That will be useful in school exams. Okay, so let's say the first example, example 1. I am writing CH3 CH2 CH double bond CH2. This is the first example. Now can you tell me what is the name of this? This is my parent carbon chain, correct? So what is the name of this compound? But-1-ene. And what is the formula? 4 carbon atoms. So C4, hydrogen 3 plus 2 5 plus 1 6 plus 2 8, C4H8. Now I am drawing another compound, and you need to tell me how these two are related. CH3 CH double bond CH CH3. This is the compound. Now how you can relate this? Again I will select this as my parent carbon chain. Okay, Now if you see in this parent carbon chain, 4 carbon atoms are here. Here also 1, 2, 3, 4 carbon atoms are there. But while numbering, I understood this is 1, 2, 3, 4. So this is the compound name is butene. Here it was 1, 2, 3, 4. That's why but1ene. So you can see the position of the double bond has changed from 1 to 2. So that means again if you see the formula 1, 2, 3, 4 C4H8. So that means both are having the same general formula, same parent carbon chain, but their position of the double bond is changing. Then this comes under the category position isomers. I hope it is clear for you. Next we will see the next example. Okay. So we will see the example 2. I hope with that you will get more clear idea of position isomerism. This is very important for exam. They used to ask this earlier actually. Okay, so let's write the next example, that is example 2. So CH3, CH2, CH2, CH2OH. Can you name this compound? So you have a functional group here. So I know this is my parent carbon chain then, correct? So if I number it, functional group should get the number 1, 2, 3, 4. So what is the name of this compound? Butan-1-ol. Correct? So what is the formula? 1, 2, 3, 4. 4 carbon atoms. Hydrogen. 3 plus 2, 5 plus 2, 7 plus 2, 9 plus 1, 10. And you have 1 oxygen. C4H10O. Now let me draw another one. Then try to tell me how these two are related. Okay, CH3, CH2, CH, CH3, OH. Try to see how these two are related. So first we calculate the general formula. 1, 2, 3, 4. Here also 4 carbon atoms. Hydrogen 3 plus 2, 5. 5 plus 3, 8. Plus 1, 9. Plus 1, 10. C4H10O. So both are having the same general formula. Now my principal carbon chain, OH group is connected to this carbon. So this should be part of my parent carbon chain. So if I count here also 4 carbon atoms in the parent chain. Here also 4 carbon atoms in the parent chain. So while numbering, I should give the least number to the OH. So this becomes butan-2-ol. So that means with these two, the parent carbon chain remains the same, but the position of the functional group changed from 1 to 2 here. So position is changing means it comes under the category position isomers. Correct? So in the first one, the position of the double bond was changed. In the second one, the position of the functional group was changed. Now let's see one more example for the position of the substituent getting changed. Okay? So let me give an example so that it becomes crystal clear for you. Okay, so we will go to the third example, example 3. Let me say CH3, CH2, CH2, CH2Cl. This is the compound. So how will you name this compound? So I know this is my parent chain. So there is only a substituent present. So 1, 2, 3, 4. So I can say this is 1-chloro-butane. Now what is the general formula? 4 carbon atoms are there. So we say C4. Hydrogen 3 plus 2, 5 plus 2, 7 plus 2, 9. C4H9Cl. Now let me draw another one. Now try to tell me what is the relation between these two. CH3, CH2, CH, CH3, Cl. Now try to name this compound. I know this is my parent carbon chain. Correct? So while numbering, only substituent is there. This substituent should get the least possible number. So 1, 2, 3, 4. So what is the name of this compound? 2-chlorobutane. So if you compare this one with this one, the parent carbon chain still remains the same. 4 carbon, here also 4 carbon. But the position of the substituent has changed from 1 to 2 here. Both are having the same formula, C4H9Cl. So this also comes under the category position isomers. I hope these two isomerism is clear for you. Now we will see the next isomerism in the next class. Okay.